If we're looking at inverse functions, when we first started looking at inverse functions earlier in the year, and then even last year when you looked at them, we said that in order to prove that two functions are inverses, if we take the composition of the two, we should always get whatever x is. And if we go this way, take the composition of the inverse with the original function. If they're inverses, we should always get x, or whatever that x value happens to be. And the same thing holds true to a certain extent with these inverse trig functions. Remember, and it's up on the board, we said that for the sine, our domain is restricted to negative pi over 2 to pi over 2. And what was the range for the y equals sine x? Negative 1 to positive 1. And so for the inverse function, let me just do that in a different color. They switched. This became the range, and this was the domain for the inverse function. Does that make sense the way I have the color changed? All right. So if negative 1 is less than or equal to x, which is less than or equal to 1, we have the composition of the sine with the arc sine, or inverse sine, however you want to put it. If this x value, the domain of the inside function, is between negative 1 and 1, then this is just equal to x. And it can save us a lot of computation time. Now, there's no big significance to why I'm using x or y. It's just to show two different values. Or if negative pi over 2 is less than or equal to y is less than or equal to pi over 2, and we take the arc sine of the sine of y, that's just going to be equal to y. Notice this has to do with the domains of the inside function. Well, I'm running out of room, but domains of the inside function. So let's just look at a couple of examples. If we want to find the sine of the arc sine of 1/2, does 1/2 lie between negative 1 and 1? Yes, so we can just look at this and say that the sine is 1/2. Now, it's possible to do this the long way. We could say, okay, what angle has a sine of 1/2? If I'm going to work it out the long way, what angle has a sine of 1/2? Pi over 6. What's the sine of pi over 6? 1/2. So if we'll remember that we can check if this value is between negative 1 and 1, and this is the arc sine on the inside, and this is between negative 1 and 1, then the answer is just whatever this is, if these are inverse functions. So let's look at one more, just to let's think about the sine of the arc sine of the square root of 2 over 2. Again, does that lie between negative 1 and 1? I think it does. All right, so this is just equal to square root of 2 over 2. We want to think about it the long way. The angle whose sine is the square root of 2 over 2 is what? Pi over 4. So the sine of pi over 4 is simply the square root of 2 over 2. You just save yourself a little bit of time if we recognize those inverse functions. And let's look at another restriction. If, again, negative 1 is less than or equal to x, is less than or equal to 1, and we take the cosine of the arc cosine of x, as long as x is between -1 and 1, we get x. In this case, if y is between 0 and pi, and we take the arc cosine of the cosine of y, we get y. Notice these restrictions have to do with the domains of that inside function when we take the composition of the inside function. So if I wanted to take the cosine of the arc cosine of 0.54, the domain of the inverse cosine has to be between -1 and 1. Does this fall in that domain? So it's just equal to 0.54. Now, if I wanted to find the arc cosine of the cosine of pi over 6, this is just pi over 6 because it lies between 0 and pi. The sine, well, let me do a different one because we didn't do too many. Let's think about the arc sine of the sine of negative pi over 4. It's going to be negative pi over 4 because that does lie between negative pi over 2 and pi over 2. Is that making sense, Max? Okay, we have to keep in mind what those restrictions were. So let's look finally at the tangent. Okay, so if we're going to look at the tangent, in this case, if x is between negative and positive infinity, in other words, x can be any real number, then the tangent of the arctan of x is x. So that makes that one pretty easy, as long as x is a real number. And negative pi over 2 has to be less than y, which is less than pi over 2, then the arctan of the tangent of y equals y. So if I wanted the tangent...
Is there a reason why you're using x's and then y's?
No, other than just it's differentiating between the two. So it's not significant as far as the x and the y on the unit circle. The tangent of the arctan of negative 14. Negative 14 between negative infinity and positive infinity. So this equals negative 14. What is the sine of the arc sine of 3/10? Christine?
Would it be 3/10?
3/10. Molly, you have a question?
What happens when you have something that's not in those?
Okay, we'll look at that in just a minute. Okay, what about the sine of the arc sine of pi? Can we have a value here? Is there any angle whose sine is pi?
Isn't it?
Is there any angle whose sine is pi?
Isn't it 180?
pi and 180 degrees are congruent angles in radian measure, but can we ever get a value of the sine that's greater than 1? Is pi greater than 1? Yes, so this is no solution. All right. To answer your question from a second ago, Molly, let's look at a problem. Because that's a good question. Because always we're going to come up with things that don't always fit this particular pattern. And you can just work it from the inside out. All right. Notice here, this isn't, that angle is not between negative pi over 2 and pi over 2. So what we've got to do is figure out what's that value. What's the sine of 5 pi over 3? What's the sine of 5 pi over 3? What quadrant are we in? 4th, 3rd, 2nd. 4th quadrant. So what does that tell us about the sine in the 4th quadrant? It's negative. And what's the value if the reference angle is pi over 3? Square root of 3 over 2. Okay, now, so we're working from the inside out. We're solving that middle part. Now, what angle has an inverse sine of negative square root of 3 over 2? Negative pi over 3. Okay, so you just kind of work from the inside out if this is not between negative pi over 2 and pi over 2. So if I have the arc sine of the sine of 3 pi over 2, is 3 pi over 2 in the correct interval? No. Well, no, we can get a solution. There's 2 ways we can do this one. Okay, what is the sine of 3 pi over 2? The arc sine of negative 1, what angle has a sine of negative 1? Negative pi over 2. Okay, we can work it from the inside out. Or you can recognize immediately that 3 pi over 2 and negative pi over 2 are the same thing and replace that. Alternatively, you could say the arc sine of the sine of negative pi over 2, and so that equals negative pi over 2. If you recognize that angle. But you can always work it from the inside out.
Wait, how would you?
Because hopefully you would recognize that 3 pi over 2 and negative pi over 2 are the same angle.
Yeah, hopefully I recognize that.
But if you don't, what's the sine of 3 pi over 2? It's negative 1. And the angle whose sine is negative 1, anytime we're using the inverse, we're looking for inverse, we have to be between negative pi over 2 and pi over 2. Did the light bulb go off or on?
Yes.
Yay.
Is that just for the sine, or is that for all of the trig functions? At any time we're looking for them, just has to be between negative pi over 2 and pi over 2.
For the sine, it's negative pi over 2 to pi over 2 inclusive. Tangent, negative pi over 2 to pi over 2 with parentheses. Cosine has to be between 0 and pi. Okay, because of those restrictions we made looking at the graphs. Did your question get answered?
Yes.
All right. Let's just look at a couple more here. Let's say the cosine of the arc cosine of negative 1/10. What would this be? I'll give you a clue here. If it's not one you know, then it's probably, does this fall between -1 and 1?
Is that negative 1, 1, or?
Negative 0.1. Does that fall between -1 and 1? So the answer is -1/10. All right. Let's look at the arc sine of the sine of 3 pi. Yes.
Cosine, so it have to be between 0 and pi, right? Like the y-hat.
Yes, yes. Okay, does 3 pi lie within my appointed interval? No. But can we find the sine of 3 pi? What is it?
0.
It's 0. So the angle whose sine is 0 is, it's 0. Because we can't use 2 pi. Because we have to be between -pi/2 to pi/2.
Wait, how is it equal to 0?
The angle whose sine is 0,
Wait, where's 35?
pardon?
Where's,
The angle whose sine is 0 is 0.
what? I'm talking about the second step. How is the sine of 3 pi 0 to be given? Where is 3 pi on the, where is 3 pi on the circle?
You go around another pi units. But we also know what the graph looks like. Because the graph, remember, see, this is so helpful at pi, at 2 pi, at 3 pi, we're at 0. So, or you can go pi units. After you've gone 2 pi, you just go around again. But the graph to me is so helpful if you'll learn what those look like. Did you have a question, Kathleen? Good. All right. One more thing. We can use right triangles to help us. Let me pause. So we can use right triangles to help us find exact values of the composition of inverse functions. I really think you'll find this is not bad. Okay. It looks worse looking at the problem than it actually is. Molly, this is a case where you were asking a minute ago, does it have to be inverse functions? These are not inverse functions of each other, right? So that composition of inverse functions doesn't hold those rules we just talked about. But if we want to find the tangent of the angle whose arc cosine is 2/3, it's really not a difficult thing to do if we'll draw ourselves a right triangle. And I'm just going to let that be theta because it's easier to use. And cosine, how do we find cosine in a right triangle? Adjacent over hypotenuse. And if I have two sides of a right triangle, can I find the third side? All right, so the third side, remember, we use a squared plus b squared equals c squared, where c is always the hypotenuse. So we have 4. So b squared is 5, and b is square root of 5. All right, so then what's the tangent of that angle? Square root of 5 over 2. Sokotoa. Yes.
I was like, why is this happening?
Yes. All right. What about if I want the cosine of the arc sine of a -3/5? Okay, now here what we have to consider is what quadrant is this going to be in? If this is a -3/5 arc sine, what did you say? Fourth quadrant. So what do we know about the cosine in the fourth quadrant? It's going to be positive. So that's where it helps us. That's why we have to consider the negative, because it tells us what quadrant, so we know whether it's positive or negative. Yes?
Can you explain again how you know that -3/5 is in the fourth quadrant?
the angle whose sine is negative 3/5. It's arc sine, so if it's negative, it has to be fourth quadrant.
Oh, okay.
Okay.
Because you're using the sign restrictions.
Yes. Okay, so let's do our right triangle. And this time, we're looking at the angle whose sine is 3/5. So this is a 3, this is a 5. What's this side going to be? 4. William?
So when you were like checking which quadrant it was in, your only options were 1 and 4.
For sine, inverse sine, yes.
Okay, got it.
Okay, so what is the cosine of this angle? All right, 4/5. Yes?
Do these have to still follow the restrictions?
If you're using inverse function, the inverse function part does. Okay, let's do one more.
Wait, what did you just do?
What do you mean, what did I just do?
How did the negative 3/5 become positive?
What do you mean, how did it become positive?
Like,
The cosine of an angle that's in the fourth quadrant is positive.
but how did you get the like triangle? I mean, like,
Can you have negative sides on the triangle?
no.
No.
you just
So I
got-
considered what quadrant I was in before I did my triangle.
How does the quadrant affect the triangle? Though?
It doesn't affect the triangle, but it affects the cosine of the angle.
Okay, so you just like absolute value that stuff.
To do your triangle.
Okay, got it.
Yes, to do your triangle. All right, so if the arctan is negative 3/4, which quadrant are we in?
No, the fourth.
The fourth quadrant. So that tells me my answer for the cosine will be positive. Okay, so let's draw our triangle. And tangent is opposite over adjacent. So we get that same triangle again, pretty much the same triangle. What's the cosine? 4/5. Oh, that's the one we just did. Almost. No, it's not either. I didn't do the triangle right, did I? Yes.
No, you did.
Yeah, okay, it was just different inside value. Are we good there? What about if I want an algebraic expression? I don't want a number. An algebraic expression in x, and I'm going to say that this is between 0 and 1/3. So that tells me that it's got to be first quadrant, so it'll be positive. Okay, so we're not going to get a number here, but we can do the same thing. We can draw a right triangle, and we know that cosine is adjacent over hypotenuse. So if I have 3x, then it's 3x over 1. So we know that 3x squared plus b squared equals 1. b squared is 1 minus 9x squared. So b equals, or you can call that y, or you can call it whatever you want to call the side, the square root of 1 minus 9x squared. And no, you cannot simplify that. So this side is 1 minus 9x squared, square root of 1 minus 9x squared. So what is the sign of the arc cosine of 3x?
Square root of 1 minus 9x squared.
And that is the answer. What if I wanted to find the cotangent of the arc cosine of 3x? Since we're using the same inside, so I can use that same triangle, what's the cotangent going to be?
Would it be 3x times square root of 1 minus 9x over square root of, over 1 minus 9x?
Okay, and here, if you want, I'll just, on this one, I would just let, you are absolutely right. On that one, you can leave it like that, but you are absolutely right. Makes sense, cotangent is adjacent over opposite. The secant of the arctan of x. Try that one. See if you can come up with the, okay, so here's this one worked out as well. Did you get it, Peter? All right. Quiz after lunch, and your assignment is on page 348. And that will be 50 to 54 even. 57 to 75 every third. And 105 to 111 odd.